Fame?
It takes 5 years to be.
Hi Joyce. So class time, I was kind of stuck with things I had to get done and I couldn't get done, so I was using Sam and then anyway. So they finished number 13 on this page. They wrote down notes and did the example on the next page, so we're going to go really fast and see how they did. All right, kiddos. La la la. What makes an arithmetic sequence?
Difference, common difference.
A common difference, a constant difference. It's called common because it's constant throughout all the terms, right? Right. Okay, so then we were able to take a sequence that was given to us at number 13, find a common difference just by subtraction, right? That's why it's called a common difference. Okay, the eighth term, how did we find that? With a formula or with a pattern?
Well, we got both. I don't think we have a formula yet.
We don't have a formula yet, but didn't we kind of make a formula?
Yes.
How did we find the eighth term?
Plug in the one before it. Or no.
No, we actually didn't do that. That would have been recursive.
I meant to say, like, instead of. No.
That's okay. What did we do? 1 plus 7 times 1/2. What was I doing? What was I showing?
Showing the process.
Yeah. And the
How many
repeated
jumps?
addition. How many jumps? In order to get to the eighth term, there's going to be 7 terms, like think 5 fingers, but 4 spaces in between. So if we're going from the first term to the eighth term, we're doing 7 jumps of addition. So we could do 1 plus a half, a half, a half, a half, a half. Well, 1 plus a half, plus a half, plus a half, plus a half. But what's repeated? Addition.
Multiplication.
Exactly. So 7 times 1/2, and we were able to get to 9 halves. The recursive rule, what did you guys get as the pattern for how to solve?
AN equals AN minus 1 plus 1/2.
AN, so a current term, equals the previous term, AN minus 1 plus question. Is this going to be what seems to happen or what will happen with all arithmetic sequences? Why?
Also doesn't have
Formula.
Because they're all just like a constant factor one.
Exactly, so I could technically look up to the top, couldn't I say? Oh, I already did. A sub n equals a sub n minus 1 plus whatever the constant difference is. Common difference, I guess I should say. Common differences. Okay. How about the explicit rule? Is that harder or easier? Sam, can you go take these to Mr. Shea right next door? Just say they're from me. I know. It's okay. He knows they're coming. There's a period late. Okay, the explicit rule. Why is it harder?
Because we didn't cheat. We used pre-count notes.
We didn't cheat and use pre-count notes. I'm a little confused by that one.
He cheated and used pre-count notes.
Oh, okay.
He was trying to get one.
Well, can't we use the pattern that we did here though? Right? And couldn't we say to find any nth term, so it'd still be a sub n, we can start with, well, where does the sequence start? 1. Plus, how many jumps are we going to do for the nth term? Nth term, what do I mean by that? What was n for the 8th term? 8. Careful. N was 8 because it was the 8th in the progression, but how many jumps did it take?
7.
So if I was trying to find a 20th term, how many jumps would it take?
19.
It'd take, to get to the 20th term, 19 jumps. So my question is, how do I formulaically show 1 fewer than the number of term, or the number of term that I'm trying to find?
Minus 1.
So I can do n minus 1 times d. Yes, you could have gone to pre-count notes, and yes, we would have written that. However, it's also somewhat intuitive. Sure? Charlie, can I borrow you to go drag that tool cart over here so I can... The easiest way for me to get there is to do a big circle. Okay. Geometric, what's different?
Now it's multiplying.
Now it's multiplying by a constant to get from one term to the next. And this one that you guys saw, number 17, what was the common ratio? What did you find? R equals -3. What's going to always be true for any sequence where the ratio is negative? The signs are going to alter. Exactly. What was the 9th term when you guys found it? Did you all agree?
I got 1963.
Ooh, which one? Negative or positive? Let's go ahead and see if we can figure out a little intuitive formula in order to get there, which hopefully is the process you guys also use. Well, actually, in your calculator, didn't you say times -3 times -3 times -3?
-3 to the 9.
That's the 9.
Oh, we should have done 8.
Because from the first term to the ninth
Right.
term, there are 8 jumps, right?
Is that what we did now?
So we would say
Oh, there are.
the ninth term is equal to -3 times -3 to the 8th. Does that make sense? Why?
Oh yeah, so it would be -3.
Oh,
Or you could do jumpity jump in your calculator and have
No, I
The
did.
negative got messed
I
up
did.
because it wasn't in the parentheses.
I did the first term divided by the ratio times the ratio to the power of how many of which term it
Is
is.
the first term divided by the ratio?
Yeah,
Why?
because r to the n minus 1 is r to the n over
Oh,
r to the
You did -3 then.
So is it positive or negative?
Negative. There's an odd number of negatives. What did you guys get as your ninth term now?
negative 1963.
You guys agree? What Gerardo is saying is, you could have gone one term back in the progression. You could have divided by -3, you would have ended up at +1, and then you could have gone 9 forward to get to the previous ninth term, which would be the current 10th term. Recursive formula. Can't we just steal the one from up above for any geometric sequence? And what would it be? A to the n is equal to?
Oh, is that what we're trying? Oh, a to the n minus 1 times -3.
So remember the recursive just says take the previous term and multiply by -3, no big deal, yeah. And the explicit rule, let's go ahead and use what we did up above. In order to get to the nth term, we have to start where?
At -3.
At the first term, good. A sub 1 times the common ratio r, but 1 fewer jump. So plugging it in for this example, what will we have?
-3 times r to the 8. Oh, yeah.
Which, as Gerardo already saw, we can algebraically simplify that, right? Because when you multiply like bases, you add the powers. So in this case, what would it end up being? -3 to the n. Does that make sense on ABC?
Yeah.
So what do we do? Haha, George, it's your favorite. With this one.
Cry.
Aww.
I
You didn't even turn up when you said that.
What can we do?
We gotta find out the things.
Yeah.
Well, first we have to find the common ratio.
But we can't really find out the common ratio unless we know how many jumps. Yeah, exactly. They both are dependent upon each other. True. So, ideas?
I don't think so.
Come on. Neither do I, at least not right now. So now what?
So I think the 4th and 7th, we gotta draw the line.
Yeah, that's one way.
What we could
I
do
don't
is
know how to do it any other way. It's too hard to do.
what we could do is try and figure out something we can multiply by to get to the 7th term.
Yeah, I don't know.
Oops.
That's
Does Steve want me to do it?
I got it. If I start getting annoyed, then I'll have you do it.
That's such a weird laugh.
Ready? I'll be smart.
Yeah, there you go. Copy and paste.
Yeah.
Ooh, exponential.
Ta-da. Okay. So what do we have?
Crap.
3010. And he's which one? The 4th one, right? And then we have and he's the 7th one? Alright, what's going on? They told us, what's the clue? If they hadn't told us, we would have been totally sunk without.
Where we start? Geometric.
Which means, in order to get from one to the next, what are we doing each time? By
10.
a common ratio, and in this case, you can say add a 0, add a 0, add a 0. Does it work?
Yes.
Add a 0, add a 0, add a 0, yes. So our common ratio, if you wanted to do it mathematically, you could have thought of your 3010 divided by your 3,010,000 divided by 3010. And then you would have had to cube root that. Wait a minute, cube root that. Why would you have had to do that?
3 jumps.
Because it's times r, times r, times r. So we could theoretically make our own little formula, right guys? 3010 times r cubed is equal to 3,010,000. But as Amanda already said, if you notice, 3 zeros got added on, so therefore our common ratio is equal to 10. That's the first part. Are they asking us anything else? Ooh, find the first term. What? How do we get that? Yeah, we could divide by 10, divide by 10, divide by 10. What's a formulaic way of finding the first term?
A1 equals
3 times A1 equals A4.
No, not 3 times A1.
A1. Oh, 30 times A? No.
You could do A1 times 10 cubed is equal to 3010, right? Because we have times r times r times r. So then in order to find A1, we could say 3010
No one says sauce. All day.
lame sauce divided by 10 cubed. Okay, double check me. Does that sound right? Because if we know our common ratio is 10, we need to go ahead and divide by 10, divide by 10, divide by 10, or divide by 10 cubed. That's what the mathematical ones would do. And if we divide by 10 cubed, doesn't that mean move the decimal 3 places to the left? So we have a 1 and a 2 and a 3, 3.01. Does that make sense?
Yes. How did you get a cube root of 3 over 3 dot?
Solve for r.
R. So I can say that 3010 times r cubed is equal to. So I divide by 3010, my cube root to get my r. Him times r cubed is him. So divide by him. Equals r cubed. Cube root both sides. So we got this a 1, we got this a 1, and stink. How do we do this a 1 for the nth term? You guys have seen the notation for the nth term, right? Just a sub n. How do we get it?
Math magic. It's a sub n minus 1 times r.
Close, but no.
A sub 1 times a sub n minus 1 to...
We don't want to multiply by another term. What do we want to multiply by? To get from one term to the next, to the next, to the next. Times r. How many r's?
The n minus 1.
Yeah. And since we have all this information, can't we go ahead and do 3.01 times 10 to the n minus 1? Dun, 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 dun. Does that make sense? Start somewhere, and however many terms we need to increase by is however many multiplications of r we need to do. Does that make sense? And these are the funny jumpity jump ones that George loves, because you kind of have to find one and then figure out another one and make your own little formula for it and then be able to go back. But we can only do this nicely because it's geometric, or if it was arithmetic. If it was another sequence, this could get really messy really fast.
There's factorial sequences.
Stop. There's more.
But not today.
I don't think so.
Okay.
Are there Beelzebub sequences?
You guys don't need to write this down, but I want to basically just go ahead and show you that sequence mode in your calculator, and then we need to go back to calculus. Praise the Lord, right? Okay.
Do you want us to write this down?
It's up to you if you think you need it. You can see graphically a sequence progressing, increasing, decreasing, leveling out, etc. if you learn to use a sequence mode. It's useful every now and
Do you
then.
ever use it on the AP test?
I don't think you ever have to use it, but it could be like
We can help you.
a discovery and exploration if you don't know how to solve. Yeah. So sequence mode. Long story short, go to mode, go to sequence. It's the last one. You have function, you have parametric par, you have polar pole, and then you have sequence sec, but without a U. Your n min, when you go to your y equals after you're in sequence mode, you're going to see some new options that you're not used to. Can I go ahead and just kind of scroll down so you can see? Here we go. So when you go to sequence mode, and when you go to your y equals, your n min means how are you referring to the sequence? Are you referring to the first term as a sub 1, which is common, or are you referring it as to a sub 0? So you could, if you're referring to a sub 0, then your n min would be 0. If you're referring to a sub 1, then your n min would be 1. Think of it in terms of physics. If we're talking about the initial, we're talking about when time is 0, so we might be using x sub 0, v sub 0, etc. Anyway, just thinking through why maybe starting at a 0 instead of starting at a 1. Sometimes it's easier to have an explicit rule or to make an explicit rule starting at 0. Sometimes it's easier at 1. It doesn't really matter. You'll see sequences starting at both, so I'm just letting you know. Okay, so you make the n min. This one's starting at 1 because we have b sub 1 as our first term. U sub n in your calculator is the exact same thing as a sub n in the sense of it's the nth term formula, the explicit rule, but you could also do recursive in your calculator. If you looked at this one, we had a recursive formula, right? One term built upon the previous term. What did they do? First of all, in sequence mode, n is the variable button. Do you see your x button? It can be x for a function, it can be t for parametric, it can be theta for polar, and now it can be n for sequence. Now you've seen all four. Where do you find u? I think it's second 7. There's like a little lowercase u. It's somewhere in the numbers. There we go. There are u's and there are v's to help you out. You're never going to need to graph more than 1 or 2 sequences, hence why don't worry about the w, x, y, z's, whatever. But you can use the u function notation of n minus 1 to show a recursive, meaning you could, for instance, have your calculator generate the Fibonacci sequence to the 100th term without you breaking a sweat. But to do the Fibonacci, you'd have to do a sub n, or u sub n, equals a sub n minus 1 plus a sub n minus 2, because Fibonacci is built on the 2 previous terms. And for your, do you guys see the last one? U n min. This is what's the first term, what's the initial term in the sequence. For this one, it's 4. For Fibonacci, you'd have to do 1, 1, I believe. I think you have to do both first terms, otherwise it gets confused. Anyway, so then you can see sequences. Nice thing is in sequential mode, it's already in dot mode because if you guys notice, sequences are not functions of all real numbers. It's only of integers because you can have a first term and a second term, but not a first and a half term. So you only have points. You don't have any in-betweens because there is no n equals 3.987. There's no term that maps to that. Does that make sense? Okay. Any questions on graphing calculator, at least the basics? Okay, it's saved in the notes if you guys want to go back and look at any of them. I think I stole this part directly out of your book. This is my own little version of simplifying it. But this is where we need to go. This is the second half of 9.1, and this is hopefully the easiest part for you guys because it has to do with, we're almost to the beat, right? Hold on, check it out. What does it take for a sequence to converge? The limit has to exist. It can't be infinite. If the limit is infinite, then the sequence diverges. If the limit exists, the sequence converges to that single limiting value. Which means, to figure out whether or not it converges, we just take the limit to infinity. As n approaches positive infinity, we're not going to negative th terms. That doesn't make sense. So the limit as we go to positive infinity, and just asking ourselves, the limit exists, sweet, the sequence converges, and it converges to this number. So guess what we're going to review? Limits. And guess what all the rest of examples were for class? Hey, let's find limits. Which is easy. Nice thing is, technically this homework isn't due tomorrow because we are going to take another day on it. However, if you guys notice, we're just doing limits, which explains why we're doing L'Hôpital's next section. Cool? All right. Alright, cool kids, go ahead and get out of here. You know what to do. If I were you, I would definitely